Hello. So today I have Mars and Jupiter with me. And as you can see, Jupiter is a lot bigger than Mars. And when we're talking about astronomical bodies, things like weight and circumference and surface area, those numbers are so large that they're really hard to keep track of if all we have is just our normal way of numbering things. And so that's where scientific notation comes into play. So keep in mind, we saw an example in our last video of a really big number. This is the number of cubic centimeters in a cubic mile. And notice we can write it down, but it'd be a lot nicer to write this in scientific notation. And so there's more than one way of writing it. One thing to notice is we're probably not going to use all these digits. In fact, we may just approximate this with just 4.2. And then we're going to write times 10 to some power. And of course, the power is just going to be based on how many places over did we move the decimal point. And of course, we can see we went 3, 6, 9, 12, 15. So this number could be written as approximately 4.2 times 10 to the 15th, and that's a lot cleaner than this. But we don't have to stop there. We could also write more digits if we needed to. So we could write 4.1655 times 10 to the 15th. Or we could even say this is the same thing as 42 times 10 to the 14th, because now we've moved the decimal place one less spot to the left than before. And we don't have to have a whole number to the right of the decimal. We could even write this as 0.417 times 10 to the 16th. So all these numbers are saying the same thing, and depending on what we're doing, one form may be more useful than another. So let's take a look at an example. So for this example, we're going to go back to Jupiter and Mars, and we want to know how many times heavier is Jupiter than Mars. Now, these are going to be huge numbers, and so immediately just even writing down the weight of Jupiter and Mars is going to be helpful to have scientific notation. So it turns out that Jupiter is about 1.9 times 10 to the 27th kilograms, and Mars is about 6.4 times 10 to the 23rd kilograms. And so then we can just divide one by the other and get a feel for what that difference is. So if we do 1.9 times 10 to the 27th divided by 6.4 times 10 to the 23rd, then basically what we need to do is we need to figure out what is 1.9 divided by 6.4, which if we punch that into a calculator, we get about 0.2969. And then what is 10 to the 27th divided by 10 to the 23rd, which of course we subtract the exponents and we get 10 to the 4th. And so that's our answer. So approximately anyway, 0.2969 times 10 to the 4th. Now this is a small enough notation of a power that we can write it out as 2969 because we're moving 4 digits to the right now, 4 places to the right. And so we can say that approximately Jupiter is about 3,000 times heavier. And more precisely, closer to 2,969. Now notice one could have maybe done this a little bit quicker just by approximating and knowing Jupiter was about 2, Mars was about 6. And doing that ratio, which is about 1/3, and then noticing that 27 minus 23 is 4, and quickly getting, again, about 3,000 times heavier. And so that's what we're going to see in the next section, where we won't worry so much about being precise, but we do want to have a significant figure or two of precision in our answer. But we'll see you there in the next video.